Hello everyone, welcome to Study Zone. So today I am going to solve some more problems on logical equivalences without using truth table. So let us go through the first problem, that is P and Q or not P and Q or P and not Q is logical equivalence to P or Q. So it means we have to prove that LHS is logically equivalent to P or Q. Okay, so let us consider first these things only. So look at this, here we have and here also we have and, which means we have and as the common term here, right? So we are taking this and Q outside. Then the remaining thing is P or not P. So take this P and not P this side and take Q common, and then remaining thing same as it is. Look here, we know about this, that is true plus false is equals to true, right? And then if we take P as false, which means not P is true, which is also equals to true, right? Whenever we take whether P as true or not P as true, anything, we will get the result as true only. That's why we are taking here true. And then this is as it is, that is not Q or P and not Q. Now look at this, here we have true and Q, right? Here and means multiplication, that is true into, let's take Q equals to false, okay? So true into false is false, and then another scenario, that is Q is true. So true into true is true. So here look at this, the value of Q will decide what is the output of this. So if it is true, then the output is true. If it is false, then the output is false. So we can consider it as Q or P and not Q. Done. Now we are taking distributive law because here we have different symbols. So look carefully, if we have different symbols, we have to take distributive law, okay? Different symbols, right? It is of the form of A plus B into C equals to A plus B into A plus C, correct? So we are taking the same form here, that is first we have to take this one and then we have to take this one, that is Q or P and Q or not Q, correct? Q or P and Q or not Q. So now we have Q or P. Now look at the RHS. We need P or Q, correct? So we are shuffling these terms, which means in the place of P we are writing it as Q. We are just shuffling this one. So P or Q and true. Here true because same thing. If we take Q as true and then or means plus, if Q is true then not Q is false, right? So it will be true. In another scenario, if you take Q as false and then not Q will be true, and then this one is also true. So if we take any value for Q and not Q, it will be true, right? So P or Q and true. So here same thing, let us assume that P and Q is true. So true and true will be what it will be? It will be true, right? And then false and true, it will be, that is 0 into 1, that is 0, right? That is false. So here it depends on this P or Q. So we can neglect this one. So the final answer is P or Q, which is logical equivalence to P or Q, that is in the RHS. Hence LHS equals to RHS, right? This is the solution for first problem. Now let us solve the second problem, that is not P and not Q and R or Q and R or P and R is logical equivalence to R. Okay, which means we have to solve this LHS is logically equivalent to RHS, that is R. So now let us consider this thing first. Okay, we have to write this one as it is, the first term as it is. In the second term, what we have to do is, look at this. Here we have this one also have same symbol. Here since both R have same symbol, we can take this R as common. So here Q or P. Look, Q or P and R. Done. So this one as it is. Now here this is of the form of A into B into C. We can also write it as A into B into C. Correct? So writing this as this one, which means A into B. So not P and not Q and R, or P and Q and R. Here we are just shifting P this side and Q this side, that is P or Q and R. Done. Now look at this. Not P and not Q. This comes under De Morgan's law. That is not P and not Q will be equals to negation of not Q, negation of P or Q. Right. So here we are applying De Morgan's law, that is negation of P or Q and R. Done. So this one as it is, P or Q and R. Now look at this. Here also same thing. Here we have and R and here also and R. So now also we can take this R outside, that is common term outside. So the remaining term is negation of P or Q or P or Q. So negation of P or Q or P or Q and R. So now here we have P or Q and here also we have P or Q, right? So we can take this P or Q as P. Just to simplify, assume P or Q equals to P. Okay, which means negation of P or P and R. So to solve this, we have negation of P or P, right? If we take P as true, which means not P will be false. The answer is true. Correct. If we consider P as false, then not P will be true. So the answer will be true. So if we take negation P as true or false, if we take negation P as true or false, the result will be true. So we can substitute in the place of not P or P, true. Correct. And then true and R. This one, for this we can take same like this, true and R, which means true into, at first let us take true as, R as true, right? True into true is true, and then let's take R as false. So that is also false. So look at this, here it is same. So the result is completely dependent on R, right? So here we can substitute this true and R with R. So now look at the RHS part. The answer is R. So here LHS is equals to RHS. That is LHS is equals to RHS. Hence the proof. So this is the solution for second problem.